Okay, ignore this part, you guys. This is for first period because they're a little behind. So again, tonight you're doing 1.4.2 RMP. All right, so what we're going to do today, I'm not going to have time to go over homework with you guys. Tomorrow we definitely will take the time. Today, I'm going to give you 10 minutes. No, I'm going to give you 7 minutes to... Are you kidding me? Are you kidding me? Are you kidding me? What are you guys, kindergartners? Okay, guys. So, yesterday most of you guys got up to E, right? Oh, you know what? Then we're just gonna start the lesson. Wonderful. Okay, so I made everybody get up to E, right? So get out the circle that you made yesterday. Okay. I'm gonna borrow one person. Okay, Kenyatta had a good one? Have it. That is pretty nice. I wish there was a way to freeze it. There isn't though. So there should be a way to freeze it. Do you mind if I hold on to this, Kenyatta? You don't mind. Okay. This is Kenyatta's. I know. Okay. Now every time you interrupt me, I'm just going to multiply that by 30 seconds. Okay?
Sorry, guys.
Alright. So if I have to stop for 2 seconds, that's 60. That might be a little much. Okay. I'll multiply it by 10. Okay? That's lowering the standards. 15.
You just said 10.
We're a family. Okay?
You just said 10. Why?
Be quiet.
Alright. Wonderful. Okay, so here we have a circle. This is so exciting. Now the exciting part is that everybody, not everybody, but all your groups had different sized circles. Doesn't matter if your circle is like this, or if it was bigger or smaller, or if it was tiny. So just for that visual effect, I'm going to go ahead and make a smaller circle here. Okay, now you know all circles are similar. Okay, you were supposed to put P as the center, and then you were supposed to, okay, well let's just review what we did yesterday. What we did, okay, we took a disc, okay, alright, so we took a disc, okay, and you wrapped some tape around it, and this we called what kind of tape? We call this a circumference tape because if you straighten out this tape, the length of this tape is the same as the length of the circle's circumference, right? What is the circumference? The circumference is a distance around a circle, right? Wonderful. Then you took that tape and you marked something on it. What did you mark? The length of one radius. Okay, so let's make sure we don't have these three words confused. Okay, radi-you, radi-me, radi-us. Okay, radius, radii, radian. What is a radius? A radius is the length from the center to the circumference of a circle. It's also half of a diameter. When we have more than one radius, we call them radii. Syllabus, 2 syllabuses will be racilla. An octopus, 2 octopuses will be octa. 1 lexus, 2 lex. Kidding, I don't know. 1 platypus, 2 plata. No, platypus, plural platypus is still platypus. Says Jorlan. That's what I learned from him this morning. Okay. Pabla. Okay, so. Okay, that's enough. All right. So the funny thing is, it didn't matter whether our circle was big or small. How many radii did it take to make up the whole circumference? 6 and then some. And we learned why. We learned that the reason was because, if you don't mind, Kenyatta, the circumference of a circle is pi times diameter, but a diameter is really 2 radii. So the circumference is really pi times 2r. So you're telling me that the circumference and the radius have a directly proportional relationship. Meaning, if the radius is small, the circumference will be small. If the radius is large, the circumference will be large. It's directly proportional. Because the circumference is whatever the radius is multiplied by how many multiples? 2 pi of them. You need 2 pi radiuses to get to a circumference. Radii. How much approximately is 2 pi? 6.28. So the circumference is really about 6.28 times the radius. For every circle. What is going on over here? Okay, so whatever the radius is, you get 6 and then some of them, and you'll get the circumference. Yeah? This is something you should have learned when you learned circumference in 7th grade. But if you didn't, here we are. Okay? Now, the beauty of it is then you wrapped it back around the circle, and then you marked, okay, them on this thing, okay? So how many marks should you have had? 1, 2, 3, 4, 5, 6, and then some. I asked you to label the center P, and the first mark A, and the second mark B. Okay, now here's where the beauty begins. Watch me. Okay. All right. If this is the length of one radius, right? But everybody has a different size radius. His might be hers might be 2 centimeters. Somebody else might be 4.5 centimeters. So let's just call this 1 unit. Okay? It's a 1 unit. I'm gonna let the length of the radius be 1 unit in my. Huh? Yeah. Write this down. Yeah, I know.
If ours wasn't, if we didn't start like exactly at the points you started, it's okay?
Yeah, it's okay. As long as you did it right, it should be the same on every circle. Okay? All right. How much is this thing? Should be 1 unit as well because all the radii are the same length. Okay. Now this doesn't look quite right, Kenyatta. I'm gonna. Okay, but. Is this? Are we wasting time now? Okay, so my question to you is, how? What? Okay, first of all, what is this called?
An arc.
This is called an arc. Okay? Yes, that's why the symbol for the arc program is an arc. Have you noticed? Okay. Are we stopping?
No.
I think we are. I'm stopping. Thank you. All right, so this is an arc, arc AB. An arc is just a piece of a circle. Okay? It's not the whole circle, it's just a piece of it from here to here. How do we measure arcs?
The angle.
Okay, we use the angle. Technically, the central angle, very good. Technically, the measure of an arc is the length of that arc. Okay? So how long is this thing? If I were to flatten it out, how long would it be? Well, think about it. Where did these tick marks come from? It came from here. And this was from 1 radii, which we decided was this 1 unit. So isn't this distance also, if you were to flatten it out, 1 unit? It's not a triangle. Okay? Okay. The distance from here to here. The distance from here to here is from right here, right? It was from these tick marks. And these tick marks we found the radius of our circle and we marked them, didn't we? Each tick mark represents the length of 1 radius. So from here to here, how long is this? It should be 1 radius, which is 1 unit, right? Okay. Let that sink in. Okay, so if this is 1 unit, which is the length of 1 radius, that is how we define what this angle is. This angle is 1 radian. Radian. Okay, radian. Okay, radian. So you know how we measure degrees with, and then we put a little circle up here, a little bubble? For radians, we put a little r. To be honest, we don't really put that r after like tomorrow because we always use radians, so we don't need to distinguish it. We just say it. But if we're comparing it to degrees to distinguish, put a little r there. So much so that I forgot about that.
Is that what
until
everybody else uses?
Everybody else? Yes.
Europe?
Oh, no, it's not like that. It's not like, oh, you know how I kind of compared it to inches and centimeters? No. The truth is, everybody uses degrees, but mathematicians use radians. Because degrees is an arbitrary system that is based on the fact that our sun goes around the earth 365 days. But why does that have to affect our angles? Right? But the radians is based on a circle. Right? What was that? Excellent question, which we will answer in a minute. So he wants to know, Jose wants to know degrees to radians. He wants to know 90 degrees is how many radians. I love that question because he wants to kind of get a sense for it. Remember yesterday I wanted you guys to have a sense. If 1 inch is this and 1 centimeter is this, then I want you to have an intuitive idea of how much, radian is. Okay, all right. So whoa. So wait, you're telling me that if my arc is 1 radius long or 1 unit long, then that angle formed by that arc is 1 radian, right? You know what the word radian comes from? It's a radius angle. It's the angle formed by laying 1 radius on the circumference of the circle. If you take the length of a radius and you curve it and put it on the circumference of the circle, the angle formed by that arc is 1 radian. It's a radius angle. Okay? Now, think a little bit. You guys already mentioned it, but back in geometry, we learned that the central angle is equivalent to the arc length, while the inscribed angle is half of the arc length. I already told you what. Don't look up your notes from geometry. I told you to save. Okay? Arc length. Okay. Alright, so isn't that interesting? That if this central angle is 1 radian, then the arc length is 1 radius. You with me? Jolly good day, Paulino. Thank you for interrupting my class with this very important announcement. Okay? Okay. All right. So you guys with me?
Yes.
Now this whole time you have been listening to my explanation of what 1 radian is, but that is only half of the learning process. In order for you to really process this, you have to be able to explain this to a lawyer. Okay? You have to be able to explain this to somebody who's picky, who wants to know why, and wants you to explain it to them in precise language. So you need to go put on your uniform shirt, and you need to talk to your partner and explain to them what is 1 radius, but the partner needs to be like, I don't get it. Can you, but why? Can you explain? But why? Okay, so take 1 minute to explain to your partner. Okay? What is a radian? What is a radian?
I don't know.
What is a radian?
No, but think about it.
Jay, what's wrong? You shut down. All right, that's what my mom yeah. Sure, sweetie. How about this? If you're confused, look at your math notes. If you're confused, look at your math notes. If you feel a little sad and confused, read the math notes. Right here. If you don't know what words to use, read this. But it wouldn't be 40 because that doesn't look like 40 radii. It looks like 1 radii. Alright, let me have your attention back in 5, 4, 3, 2, 1. 0. Alright, are there questions right now based on, you might have found yourself being more confused than you thought you were, because you thought it made sense when I said it, but when you tried to say it, you realized you were lost. Are there, so you see how it's listening? What Ms. Patel says is true. It's not just about sitting and listening. You also have to actively participate. When you're explaining to somebody else, that's when you're participating. Are there questions right now? Yes.
What if the units were different, like it was 2 and 3?
Okay, we're going to talk about that in 1 second. That's a very good question. We're going to talk about that in 1 second. Are there other questions? Yes.
Wait, so the arc has to be the same as the radius
Central angle, yes?
to assume that the angle is 1 radian?
No, that's always true. In geometry, the length of the arc is always is equal to the central angle. So if this is one radius is long, then this is going to be 1 radian. If I lay out 2 radii here, go to the second tick, then how much is this angle going to be? 2 radians. Okay?
It doesn't have anything to do with the actual radius, like the length.
It does. That's why. Okay, very good question. So Carla's asking a good question. Look, on this circle, do you notice the circle's a lot smaller than the circle? But same idea. If I start with 1 radius here, and let's say I'm going to go this distance, wrap it around, okay? So this is 1, and this is 1. Well, how much is that angle going to be? That's going to be 1 radian. Okay.
If it's 60, what would be the center angle?
Okay.
There you go.
Go ahead. Jay? Why is the arc equal to the radius? That is the way we defined it in geometry, because we said the whole circle is going to be 360 degrees and the central angle around the circle is 360 degrees. But it just so happens very nicely on a unit circle. We'll talk about it in a second. Yeah. Okay, so before we get there, you guys, look at mira. Yes.
No, wait. So the radius is gonna stay the same. It's 1.
Yes.
But what if the arc were smaller? That's not a radius.
Yes, okay, so very good question. So let's do this. You guys don't have to draw this, you just watch me, okay? If I go... No, because then the people watching the video can't see it. Okay, so here, do you see this blue angle right here? I don't know, just... I'm recording this for you guys so you can watch it at home. Okay? Okay, how much... Okay. 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 What is the arc length of this arc? I put 2 radii here, right? Well, this is the length of 2 radians or 2 units. So that's 2 units. So how many, I want to say degrees, but it's not degrees. How many radian is this angle? 2. He's not here. Yeah.
What if it was split? Like it was 2. What if it was like 1.762?
That's fine. That's fine. Okay? Now, yes. Say it again.
If like you know how it's like if it's two like radii and then 2 units for the arc, what if it was like 2 different numbers instead of the same?
It can't be. The definition of the arc length, it's a good question. The arc length is always going to be equivalent to the central angle. Okay? Now, let's talk about one more. Okay. Mira. What if I go starting here? Although I really shouldn't start here. I should have started in a different place. Forgive me. Okay? I'm going to go from here to here. Okay? And that green looks so much like that yellow that it's not helpful. Okay. Okay, the blue. How many radii lengths did I have to go for this arc length? Okay, so this is 3 radii. So how much is this angle gonna be? 3 radians. Yes.
How many radians in one circle?
Great question.
28.
He wants to know in a full circle how much degrees is it? So you want to know how many, right? Okay, we're gonna talk about that. But first, let's talk about this one, okay?
180.
Okay. Great questions you guys are asking. Okay, mira.
Wait, so wouldn't that mean that 90 degrees is before radians?
Hold on. Hold your horses. Okay. All right. Wait. So 3 radii looks like this, right? It almost looks like a half circle.
Almost.
So 180 degrees should be a little less than 3 radians, right?
Wait, we can't see your blocking.
Oh yeah, a little more than 3 radians. No matter what I do.
No, it's because
Yeah.
Like,
Okay, fine. I'm just kidding. I know. Okay. You guys with me?
Yeah.
Okay. Let us transfer ourselves over. No, it'll come back. Don't cry. Woman, don't cry. Okay, so please get out your packets.
Women don't cry.
Yeah, keep going. Keep going. This is the best one yet. Because I taught it to the other class a little differently, but I realized that Kenyatta circle was really good. It was just helped me a lot. And it wasn't just a circle.
That's extra credit. That's extra credit right there.
All right. By the way, if you're ever confused, if you don't understand me, maybe you understand the math notes. Okay? That's what I did in college. I learned everything from the books because I didn't understand my teachers. Okay.
Yes, I did like that too.
All right. Assuming the radius of your disk is 1 unit. Okay? If this is 1 unit, what is the exact circumference? Well, what is the circumference of a circle? 2 pi r. But if the radius is 1 unit, write this down. What is the circumference? The circumference is 2 pi, yeah? But we just said the length around the circle is the same as the actual unit measure, the essential angle. So if a whole circle is 2 pi, then the whole circle is 2 pi radians, right? Okay. So to go around, I need you guys to understand that on a unit circle, what we just said here is on a unit circle. A unit circle is a circle that has, what is a unit circle? It's a circle whose radius is exactly, that's a unit circle. On a unit, anything, 1 unit. It could be 1 centimeter, 1 inch, one nail, 1 mile, yes, very much so. Okay, no, not gallon. How much? Okay, the circumference of a unit circle is what? It's 2 pi. On a unit circle, I need you guys to keep this in your head forevermore. Amen. On a unit circle, the circumference is 2 pi. Because it's 2 pi r, but r is 1. So circle, 2 pi. Yeah? 2 pi. Okay? Which is about what?
6.28.
All right. Huh?
That says what? R equals 1, right?
Yeah. Thank you. All right. Questions so far?
Wait, don't change it.
Okay. You know you can always go home and watch this video. Okay. All right. Next page. Okay. Don't cry. Just write fast, okay? What? All right. Okay. Look again at the circle that you traced on the paper. Let the length of the radius equal 1. Okay, very important. The thing about this book is it's different from textbooks. Textbooks, they give you a vocabulary word, they highlight it, they put it in the box. Here it's like this very important word is hidden in this parenthetical statement. So you have to be opening your eyes wide. That's an important important vocabulary word that's ensconced in this problem. Okay? Escondido. Get it? Ensconced means hidden. This important vocabulary word of your literary experience is ensconced within this problem, so you must be seeking. Okay? All right. No, but how awesome is this? Okay. How many degrees? How many degrees did you go around the circle in order to make 2 pi radians?
I have no idea.
360 degrees.
Wow.
A radian is a unit of angle measure. The central angle of a full circle is 360. So how many radians is this? Can you tell me more exactly? Now more exactly. Okay. So what whole number does this approximate? About? No, that's not a whole number. 6. So we're gonna put that in our head. So we're gonna memorize these. 360 degrees is how many radians? 6. No, exactly how many radians? Okay. No. Well, you can put it next to it. But here's the thing, you guys. The whole point of this activity was for you to get an intuitive idea of a radians, but you actually don't need to know it. To be honest, I never knew until I taught pre-calculus for the first time a few years ago what 1 radian looked like, because we never talk about 1 radians. We don't count you know how like cents, we don't really count it in terms of 1 cent. Like how many often do you buy something that's like 3 cents? We don't talk about cents in terms of 1s, 2s, and 3s. We talk about cents in terms of 25s or 5s or 10s, right? Same thing with radians. We don't really talk about 1 radian, 2 radian, 3 radians. We talk about pi radians, half pi radians, 2 pi radians, 4 pi radians, pi over 3 radians. Okay? So, yes. Did you get what I said though? Did you get what I said? Okay.
Yes.
You don't talk about it like as an individual.
That's right. But just in case you're wondering, 1 inch looks like this. 1 centimeter is like this, right? Well, angle-wise, 180 is like this. Okay, forget that. Okay, so.
Whoa.
That's not gonna work. Okay.
Wait, so would that mean?
Okay,
There you go.
okay, so. Okay. All right, so. Okay. All right, back in the day.
Wait, no, you gotta scoot up a little more.
This is how many degrees?
0, 180, 90, 180, 270, 360.
What about this? Negative what?
90.
Good. Now erase that from your brains. Now we're gonna use radians from now on.
That's fine.
Oh wait, no. You need to know it again. 0,
180, 0, 360, 180, 90.
Very good. Notice I always start here.
We got the negative.
Okay? I could start angles anywhere. But standard position always likes to start here. It's like in ballet, first position. Standard position goes from here to here. Okay? Standard position. Okay? Now let's talk about radians. This is how much?
0, 2 pi.
Get that into your head. This is no longer 360. I mean, it still is, but now we care about it's 2 pi. So that means this is
1 pi.
1 pi. 1 pi.
Half pi. Ooh, kill him.
1 pi.
1
okay, so 1.5 pi or 3 pi over 2, right?
1 pi.
Okay, it's more than 1 pi. Yeah? Okay, so how much is this again?
1
1/4 pi. 1/4 pi. Yeah? Fractions are better than decimals, though, okay? So show, don't tell. Okay? Okay. We should say that. Fractions are better than words. I mean, decimals. So show, don't tell. Okay, 1/4 pi.
Yes.
Half pi.
1/6.
No. No, because it's
Sorry, 1/3.
straight.
Oh, I know what you're doing.
1/3 pi, right? Because there's 3 of them. Hello. Okay. What about this? Oh wait, I already did this, right? 3 pi over 2. Okay. So how much is this whole thing again?
2 pi.
Okay. What about this? Negative pi. Okay. Negative half pi or pi over 2? Very good. That's exact. No, that's a decimal approximation. The pi is like more exact. Okay. All right. So, all right. I told you it'd be phenomenal. Okay. All right. It really is. I told my 5th period, I'm taking you on a journey and you're never coming back. Because we're going into radians and now they're like, are you kidnapping us? Okay. So, all right, so on the unit circle, again, ensconced within this problem is a very important vocabulary word. What is it?
Positive x-axis.
Standard position. Like I told you, standard position is the one that starts here. We always start there to make it easy, okay? Okay. All right. Okay, standard position. All right. So they want you to approximate what 3 radians looks like. 3 radians. Remember we did it with Kenyatta already. 3 radians looks like this. Remember?
Oh, yeah.
But let's do it in standard position this time. 3 radians looks like, well, 1 radian was this much, so another one would be like about that much, and then another one would be like that much, yeah? Yeah, it's a sketch.
Wait, so basically, so I can get this straight. So basically, the arc is the same distance as the radius.
Yes.
Okay, that's what I
Yes.
need to know. See, that's why-
Central angle is equal to the measure of the arc length, okay? So that's about 3 radians, okay?
What?
3 radians is about like that angle, yeah? Actually, I forgot. That was the whole reason I did this whole activity. So I was going to show you 1 centimeter and 1 inch, right? 1 inch and 1 centimeter, and then I was going to show you, but basically 1 degree is like this, right? And 1 radian would be like what?
More. Like that.
Show me, what's 1 radian? About like that, right? But like I told you earlier, very fast, it's not that important. I mean, I just think it's important, like for you to have in your head what 1 centimeter looks like and what 1 inch looks like. In the same way, it's useful to know what 1 radian looks like. It looks like about like this, almost a 60-degree angle. But we don't usually count in terms of 1 radians, 2 radians, 3 radians. We count in terms of pi radians, pi over 2 radians, 2/3 pi radians, 3 pi over 4 radians, like that. We count radians in terms of pi, just like we count cents in terms of usually quarters, right? Okay, good. So, wait, so this is like half a circle. So 180 degrees is about 3 radians, right? A little more. A little more. How much more? 3.14 more. So about pi. Okay? Because look at 3 radians. It looks like that. To make a whole full circle, I need a little more. How much more would I need? Okay, so hold on. Okay, so how many degrees of angle measures are there in 1/2 of a circle? Let's go faster. Okay.
No.
What? Pi is a fraction. Okay, it's an irrational number. Remember? And irrational numbers cannot be written as a fraction, but it can be approximated by 22/7. It's the closest fraction we can come to that's as close to pi as possible, but it's not exactly equal to pi, because if it was equal to, if 22/7 equal pi, then pi would not be an irrational number. It would just be 22/7.
What if the 1 was pi?
Ooh, you think about that. Okay. How many degrees of angle measure are there in half of a circle?
What? Wait. Translate that.
Thank you.
Translate that, no?
Half of a circle is how many degrees?
Oh, 180, okay. Okay, I got that.
About how many radians are there in half a circle?
3 and 5 more.
3 and then some, right?
Hey!
Oh, radii.
Okay.
That's what I don't understand. I thought you said it was like 1 when we were doing the whole thing.
Yeah.
Like 1 pi, and then now it's 3.
No, 3, not pi, just 3 as a number.
Can you say 1 pi?
1, okay. Now exactly how many radians? It's about 3, but if I ask you exactly how much, it's not 3, it's about exactly pi. You get it? Pi is about 3.
Oh, okay, so about, okay.
Little more, that's right. That's why I put 3 plus. Little more. The plus sizes, you know? Like if you're like X up. Anyway, never mind. Okay. Yeah, that's right. Now you guys need to write an equation. Now this is very important. We're going to write an equation. What is the equation? Okay. What is the equation?
90 degrees equals pi over 2.
Using the half circle.
Pi over 2.
No, half circle.
And then 180.
Well, how many degrees is half a circle?
180 equals pi.
180 equals n times pi.
So 90 equals pi over 2.
Okay, I need you guys to memorize this forevermore. Amen. Okay?
Hey, Jessica must see this.
Doesn't that make sense? Okay? If 360 degrees is 2 pi, then half 180 degrees should be 1 pi. And this is the easy. You can memorize this if you want, but most commonly we use this as our conversion ratio. Okay? 180 is pi radians, okay?
So 90 is pi over 2.
Forevermore.
Yes, sir.
When you ask, we don't have to say pi radians, right? We can just say pi.
You could just say pi, yeah. Because most of the time I assume you're using radians unless you say that you're using degrees, because that's our default mode. So good. Pablo says 90 degrees is how many
Pi over
radians?
2. Pi over 2. Then 45.
So 45 degrees is how many radians?
So am I supposed to rewrite what I wrote before?
Okay, 60 is what proportion of 180? It's a third of 180, right? So it's how many radians?
Pi over 2.
Nice. Alright. You guys with me? Okay, now we're gonna convert now. We're gonna do some conversion. We just use the relationship right here. You guys said that if 180 equals pi radians, then pi over 3 Of course, that means pi over 3 radians, since I divided that pi by 3, would be 180 divided by 3 radians, degrees, which is 60 degrees, right? But I want to show you guys, well, you guys all take chemistry, or have taken, or will take, or have taken, or are taking chemistry.
Never.
Okay, so let's think about the chemistry way, okay? Okay, pi over 3, think of this just as a number. Radians. They were showing on the screen? I was that close? How did that happen? I don't get it. Okay. Okay, if I want my answer to be in degrees, I have to multiply by a ratio. What do you guys call it? A ratio? Conversion ratio? Or unit? Conversion factor. What should my conversion factor be? Do I want radians over degrees or degrees over radians? I want degrees over radians because I want my answer to be in degrees and I want to cancel out the radians. So how many degrees goes in how many radians? 180 degrees goes into pi radians. This is the factor that you have to memorize. So of course you remember because 180, okay, just like if I ask you to convert 160 minutes, okay, into hours, okay? You're going to multiply this by hour per minute, you know? And you know that 1 hour is 60 minutes, so you would do 160 times 1 over 60 to cancel the minutes, and your answer would be in hours, right? We're doing the same thing here. We have radians, we want degrees, so you're going to multiply by degree over radians, which is really just 1. This is 1 unit. This is equivalent, so it's not changing anything except the conversion. Okay, so the radians cancel. So pi times 180 over 3 times pi. The pi's cancel. So you just have 180 divided by 3, which is? Okay, so 60 degrees. Now with this one, wasn't it much easier just to think about it as, since pi over 3 is a third of pi, then, you know, the degrees is just a third of 180, which is 60. But what if I ask you to do 200 degrees? Okay? Okay, so let's do that here. Okay, so I want you to convert 200 degrees into radians. Not pi's, radians. Okay?
Miss, you recording this?
Yeah. Okay. So, should I do degrees over radians or radians over degrees here? Very nice, isn't it? Okay. Alright, so how many radians? How many radians?
We got it on video.
How many radians? How many radians? Pi over how many degrees? So then my degrees will cancel and my answer will be in radians. 200 is really 200 over 1, you know? So 200 times pi over 180, you Miss Patel taught you could just cross out the zeros, right? Okay. So what's 20 over 18? So your answer is 10 pi over 9 radians. Okay?
Is that the unit that we're always using, 180 and pi?
That's the unit conversion, yes, the conversion factor that we use.
All the time?
Yeah.
Oh, no, never mind.
So do you guys see this chart? Does this chart make sense to you?
Hold on. Yeah.
Okay. Okay, then just for fun, I skipped it in all my other periods, but just for fun, how many, why do I talk so loud? Because you guys talk too much. How many degrees are in 1 radian?
Can you let us figure this out by ourselves?
Yeah, sure.
Okay.
1 radian equals how many degrees?
1 radian?
You guys figure it out.
Put degrees over radian.
Don't look. You guys do it on your own. Don't look and see if your answer matches mine. I can't. Oh, yeah, that's a good idea. Huh? I want to know 1 radian equals how many degrees? You're so smart. I was like trying to figure out how to pause it last period and I couldn't. Huh? 1 radian.
Yeah. That's what we got. Yeah. Yeah. He's like, yeah.
What?
Oh. Wait.
You don't know, so you can't figure that out, right? That means I don't know.
Yes, sir. And what is pi about? And so if you do 180 divided by 3, it should be about
Wait, pi over 180?
60. Sorry, 180 divided by 3.
Pi over 180?
No, sorry, 180 divided by 3. And 180 divided by 3 is about 60. But 3.14 is bigger. The denominator is bigger than I estimated. So should my answer be bigger or smaller? Smaller. It should be smaller than 60. Very good with your proportional reasoning. So who's got it? Abe? What is 180 divided by 3.14? So 1 radian es aproximadamente 57.2 o 3 regados. Okay? Okay, I like this question. Which is larger, 1 degree or 1 radian?
1 degree. 1 radian.
Show me with your hands. Arms, what does 1 degree look like? What does 1 radian look like? So which is bigger, a radian or a degree? Radian.
Alright, now explain this.
Because 1 degree is like out of 180, 1 degree is like this. But remember, look at your paper. 1 degree, 1 radian is like this.
Oh, you're right.
Okay? It takes 57 of those guys to make one of those. So who's bigger? Yeah. Okay, you guys, I want you to do these 2 problems and then we'll call it a day. Okay, do these 2 problems and we'll call it a day.
What's the problem?
130 and 131. Yeah, no calculators. Thank you, Diana. When I say half a circle, you're doing half of the whole thing, right? Half a circle is think about that for a second. Woo! Yes, of course, number 1 should be obvious. Ok, voy a poner las respuestas y tienen que chequear si estás correcta o no, ¿ok? Por favor, cheque. It's one of my favorite days ever. I love unit circle and radians. Okay, let's
Wait, Miss, I need your help.
Miss Harmless pumpkin pies?
Yeah, I do.
What? Why?
wake up. Check your answers on the board.
Oh, that's how you wanted to do it?
Make sure you can get the answer. Stop, Abraham. Actions speak louder than words. So show, don't tell.
But if you do it at a 360 or 180?
You could either use this one or this one, but if you do 360, you just do it over 2 pi. I just use this one.
So I would just do it. So that means I would do
No. It's degrees, and there's a little degree symbol there. So these guys are tricky. They're trying to trick you because they're making it look like a radian, but it's actually a degree. If you said it was 2 pi radians, then you should get, for the answer, you're converting to radians. So you should get pi squared over 90. I know. You need to unfoil your. I can't do it for you. You have to untangle that.
Does that say 2 pi degrees? Son, does that say 2 pi degrees?
Yeah.
So that means I'm supposed to multiply 2 times 3 more and then convert that into the.
Well, it really doesn't matter. I just heard the name.
Over 180.
So this is degrees, right? You just do this. Look.
I just multiplied 2
2
times 3
pi
more.
degrees.
Is it 1 then?
The answer is pi squared over 90. The answers are right there. I don't understand why you're asking me that.
I know, but I want to know how to do it.
Yeah, it's pi squared over 90. That's what, okay, so you multiply, look, degree. You know what, I don't explain it. I think you guys can figure it out. The struggle, the learning is in the struggle. You guys gotta struggle with it.
Oh, okay. So it's jump.
Don't use 3.14, that's imprecise. Use pi. Your answer needs to have pi in it. I don't want a decimal approximation.
Where'd 2 pi go?
Oh, you knew it.
Where'd it go? It converted to pi squared over 90.
So basically, if I multiply the 2 and pi,
Yes?